use triangle proportionality theorems. So our learning target today is to use scale drawings to solve problems, and we're going to learn 4 new theorems for your notebook. And the first one is the triangle proportionality theorem, which states, if a line parallel to one side of a triangle intersects the other 2 sides, then it divides those sides proportionally, not in half. TU could be a midsegment, but it is not necessarily a midsegment. It divides these 2 sides proportionally. So what does that mean? That means that if TU is parallel to side QS, then RT to TQ is equal to RU to US. So if it helps, you could think of TU as your fraction line, and this segment on top of this segment, and then here's our fraction bar again, RU on top of US, if that helps you to set up your proportion. Now we have the triangle proportionality theorem, so then of course we have the converse of the triangle proportionality theorem. And our converse says that if the line divides the triangle proportionally, so if TU makes these 2 segments proportion and these 2 segments in proportion, then it must be parallel. So if RT to TQ is the same proportion as RU to US, then I know that TU must be parallel to QS. The next 2 that we're going to learn don't actually have names, so I'm just going to put it up here. If you've got 3 parallel lines and they are intersected by 2 transversals, so here I've got line R, S, and T. Those are 3 parallel lines, and I've got transversal L and transversal M. Then our transversals are divided proportionally. So these parallel lines have created proportional segments of these transversals. So that means that the proportion of UW to WY is the same as VX to XZ. So again, if it helps, you could consider this middle parallel like your fraction bar, and then that's how it separates the segments. And then last, we're looking at a triangle and an angle bisector. So if a ray bisects an angle of a triangle, so CD is an angle bisector, that means ACD and DCB are congruent angles. Then it divides my opposite side, AB, into segments whose lengths are proportional to the lengths of the other 2 sides. So what does that mean? Well, notice that my ray cuts AB into 2 pieces. So AD to DB is the same proportion as leg CA to leg CB. So you could use this ray as your fraction bar, and as long as you do segment with segment and leg with leg, your proportion should be set up perfectly. Alright, so let's do a few examples. In example 1, I want to find the length of the segment. And I know in this diagram that BE is parallel to CE. CD, excuse me. And I'm told that BC is 12 and ED is 9, and I want to find, oh, and BA is 8, and I want to find the length of AE. So I'm just going to call this X. And you can use this as your fraction bar. You can use BE as your fraction bar, and that's what I'm going to do. So X over 9 is equal to 8 over 12. And now I simply just need to solve that inequality. So, solve that proportion. So 12x equals 72. So x equals 6. And since technically I was looking for AE equals 6. Okay. Example 2. Determine whether line segments are parallel. So this example used my triangle proportionality theorem. Example 2 is using the converse of the triangle proportionality theorem. So what I'm going to do is I'm going to consider PU my fraction bar, and I'm trying to determine if PQ is parallel to LM. So I've got 18 over 16. Is that equal, is that the same proportion as 27 over 24? So this is just simplifying fractions. So 18 to 16 can be simplified down to 9 over 8. And 27 and 24, both divisible by 3, can be simplified down to 9 over 8. So my proportions are the same. So since 9 over 8 is equal to 9 over 8, then I know that those two lines are parallel. And that's by the converse of the triangle proportionality theorem. So in example 3, we've been given that angles 1, 2, 3, and 4 are all congruent, and these particular segment lengths, and I want to find DE. Now, so I'm going to call DEX just so I have a reference for it. But before I can use the theorem we discussed earlier, I have to actually prove that L, M, and N are parallel lines. So there's a few different ways we could do that, but if you notice, my alternate interior angles 3 and 4 are congruent, so that means that M is parallel to N, and 1 and 2 are alternate interior angles, and they are congruent, so M must be parallel to L, and then if M is parallel to N and M is parallel to L, then all three of them are parallel to each other. So that's one way to prove that they're parallel. So I know these are parallel, which means that these two transversals have been broken up proportionally. So I'm going to use line M and kind of consider it a fraction bar, and now I've actually been set up, my proportions have been set up for me pretty much. So 21 over 28 is equal to my X, because that's DE, over EF, which is 32. And once you've set up your proportions, it should be fairly simple to figure out. We're going to solve 21 times 32. That gives us 672. equals 28x. So x is equal to 24. So DE equals 24. All right, last example. This is the fourth theorem we talked about today. So we were told in that theorem that if you have an angle bisector, which we do, that it's going to split the side across from it proportionally with its legs. So what we need to do is I'm going to use this BD kind of as a fraction bar. And I know that this side equals x, but I don't really know what this side equals. I know that AC is 33, but I don't know what DC is. So I'm actually just going to do some subtraction. And that gives me that 33 minus x is going to be this part over here. So I've got my fraction bar set up. So I know that if I use x over 33 minus x, so x fraction bar 33 minus x, that's going to be equal to some other fraction. So look at the leg that x is attached to, BA, that's 45. Now look at the leg that DC is attached to, BC, it's 54. And there's my proportion. So now we simply have to solve it. And you're going to cross multiply just like you always do. Remembering, of course, that 54x, remembering, of course, that when you multiply 45 by this quantity, you have to multiply 45 by 33, which will give you 1485. And you have to multiply it by the x. So distribute the 45 throughout. And once we do a little algebra, you should wind up with x equal to 15. All right, complete the 4 practice problems here and let me know if you have any questions. So here are the answers to the practice problems. ST is 15. MO is not parallel to LP. X is 34. X is 12.